Can you believe I lost my glasses again? But I didn't lose focus on this video. We're talking about math. So stand by. This video is about to start.
This is the savage scientist Ed right here. And I'm over the police car.
Saw the intro. So today we're going to focus on math. If you notice in the previous videos, I haven't talked about math a lot. So today is going to be our intro, and probably this will definitely not be the last time I talk about this subject, math in C++ programming. So this is going to be a very short video. So here's the index. Jump to the topic that you want to see, jump to what you want to talk about, what you need here. So now that we got this far in this series, don't forget to hit the subscribe button, like this video, share this video, because you see they're not getting any views. So we on day 6, math and arithmetic operations. We're going to discuss quite a few things in this video. Alright, so now it's time for us to take a look at the order of operations here as it relates to C++ and math. And you might notice, look how it says day 5 plus 1. That's because I had to redo this video for you. So you can't start talking about order of operations without going through PEMDAS, which is a common acronym used to define the order of operations. Parentheses, exponent, multiplication, divide, and that's not a percent sign, divide, add, and subtract. And in C++, we have parentheses, multiplication. I'm having extreme trouble trying to draw stars. Divide, modulus. So to add a little confusion your way, in C++ the percent sign does not mean percent, it means modulus. So just keep that in mind going forward. Addition, subtraction, and equals. And priority goes down. So just like in math, in C++, we're going to take care of whatever we have in parentheses first. And then we're going to work our way down all the way till we get to the equals. So if you notice, there's no exponent operator in C++. So we can't compute to the third power, which is 8. We're going to learn later how to do this using functions and loops. So let's take a look at a quick expression here. So let's say 2 times 3 plus 7. So we're going to just put some parentheses in here so we can make it clear on what we're going to compute first. So we're going to do our 2 times 3, which is 6, plus 7. And if we do 3 plus 7 times 2, that's going to give us a different answer. So order of operations is good, so we won't have problems with computing these values out of order. So it's time for us to do the math. To pick back up where we left off. And don't forget to hit the subscribe button while you hear me ramble on. And now let's start DevC++. So we could start practicing with a simple calculator app. This calculator app is just going to take two numbers and add them together. And guess what? I found my glasses. You don't want to play with somebody looking like this. So open up that damn DevC++ and let's start working. So go to File and open up our last program, and you're going to see all this junk again. We're going to just erase all this and start fresh. Start from scratch. Here we go. So now I'm about to declare two variables, int x and y. And this is how I declare two variables on the same line. This is the same thing as saying int x and y. I have two ways of declaring y. You could either do it like this, or you can put them all on the same line. So either way, both of these are suffice. So now we're gonna take two numbers and add them together. So let's assign them the values of 98 and 76. So we just assigned values to these numbers. So now let's do a sum. So this is how you print the numbers to the screen. We're going to just say the result. So we're going to do a cout, C-O-U-T, cout, and put our parentheses there. The result of X and Y is, and we could throw an equal sign, and we want a space between the values that we're about to return here. So we could return X plus Y just like that and do a inline. We could do our inline statement by just typing in ENDL and drop the semicolon at the end, and that's it. So now we're going to return 0 to exit the main function. Return 0, semicolon. Control S, that's going to save, and now F11 to compile and run. So did you notice any errors? Because I didn't. So the answer to this one is 174. So this is a very basic program. It doesn't do anything, but I just want you to see right here. We returned in the IOStream function, in the IOStream cout function, we were able to add two numbers. So what if we want to save the results of that? So we would say int result. And now we are storing the sum of these two numbers. We could replace that X plus Y with result now, because we just put X plus Y right here. So now we could put result. And do you want to see what's going to happen if you add a float and an int value? Float 98.1. So what you think is going to happen when you try to do this? What? Put in the comments. 50% chance that it won't work. 100% chance it won't work. Will it work? Let's see what's going to happen when we add 98.1 to 76. So here's the answer. We still got 174. But do you notice something? Where's the decimal part? We just have 174. So let's go into detail on why we still getting the 174 and we don't have our decimal part. Let's see what happened if we do 98.9. Will our results be different? So let's save, and now let's run it. So the answer is still the same. So whenever you add a float and a int, it's going to ignore the decimal part of it. And so if we had, and another thing, you can't do this. You can't just create a int value and put a decimal component to it. Let's see what's going to happen. So after saving, compiling, and running our program, the result is still 174 because we are still using an integer value to hold our result. Now let's change this to a float and run it again. And now you can see we have the decimal part of the result. So notice, we still don't have the correct sum. 76.6 and 98.9 does not add up to 174.9. So the reason why we're not getting the correct answer is because we still have an integer value representing our y's. We're going to have to change that to either float, double, or some type of precision-based number. So let's do that now. We can do double. And now let's see what's going to happen. So now we have the correct value. That'll be bad practicing to declare int and put a decimal component in it. So don't do it. Even if the compiler lets you do it, don't do it. And another thing, if you're not using a double component, just declare it as float like this. And one quick note, floats and doubles are both the same thing. It's just double takes up 2 times more space than float. So now it's time for us to add more functionality to our basic calculator by working with user input. Here we go. Enter we're gonna give it a title here. So we're gonna call this Poor Man's Calculator. That's the title here. And on the new line, we're gonna practice using the new line symbol. We're gonna type first number, enter first number. And we're gonna get the user to put in the new number. So we're gonna end line here, and we are about to ask the user for a number. CIN. We're gonna get user input, and we're gonna replace so we're gonna take the user's input and we're gonna put it in the variable X. And we're gonna do the same thing again and get Y. So let's see, we're gonna take this line and just copy it. And make sure you put it after this line, because we just got the first value, so now we're working on the second value. So we're gonna see out again, COUT, and now parentheses, enter second number. And I don't like how this compiler actually starts filling in things. So here it is. So now we're going to inline, ENDL to inline, and now CIN for, now we're about to CIN for the Y value. And now we're about to we're going to drop some more lines of code right here because we want the results. So we're going to just copy that line. Yeah, I do a lot of copying and pasting and just, let's see here, and just put the same crap here. Saves a lot of time. The result equals the result of X, and Y. So there we go. We're going to just put results right there. And another thing, we're going to move this line. We're going to copy this line, just cut it out. And we're going to paste it after we get our last user input. So we're going to we just move results down here. So now let's Control S for save and run it with F11. So here we go. Enter your first number. We're going to say 898. And now enter the second number. We're going to do negative 1000. And here it is. The result of X and Y is negative 102. So let's see what happened if we move our results back up here. Control S for save. And now I'm about to F11 and compile this again. Let's see what happens. So we're going to use easy numbers here. 1000. The second number, we're going to say 400. So we should have 1400, right? See how we still got the 175.5? This bug comes from the fact that we created our result on line 13. And then we got user input on line 15 and 17, but we didn't update it before we printed our new results on line 19. And another thing, we're using floats. So you notice how I didn't even put a decimal component in the last part? So I could have did this with ints, but we're using floats. So floats almost have the same abilities of int, but it's just that these floats take up a little more space. So as your program become more demanding, then you might decide to want to use ints where it's appropriate. If we're not going to be using these big numbers, then we don't need to use doubles and longs and all that stuff. Float will do it. But if you're not using the decimal component, then you don't even have to use floats. You could use ints. You could use even shorts. So let's change this to short. And now we could just come up here and roll with we don't even have to, we're gonna just, yeah, let's do this. There we go, 8 and 7. So we're using shorts. Shorts are even smaller value. They're integer values, but they take up less space than int. That's it. So let's Control S for save. And now let's run it with F11. Here's our calculator. So enter a number. So we're going to just put 444. And there it is, 15. So let's see what's going to happen whenever we move this down here. And the thing is, you notice how it still computed it as with the float value. So right now our results, we want our results to be in its proper form, short. We're not going to be doing this with doubles and all that. We won't be mixing. From this point on, you will not see me mixing and add numbers unless we do what we call cast. That is the proper way of converting something like converting an int to a double, or we converting a character to an integer value or something like that. That is called casting. I'm gonna have a video on that in the future, but from now on, we're gonna just use the data type that we need to. So we're using shorts right now, so we're gonna continue using shorts. The short is just a short integer value, half the size, 2 bytes. I'm thinking it's 2 bytes, but check my last video to make sure I'm correct. So now let's compile this. And we're about to put some numbers in here. So first number is going to be 44 and the second number is 24. And there we have it. It's adding and doing what it needs to do. So now, later on we're going to talk a little bit more about making it so this thing could change operations. So we want to be able to divide. You want to be able to multiply, subtract, divide, and do all that other stuff. So right now the only way we could do that is if you want to divide, then you could just change that to do this. So that's it. But we're gonna just play with these, but I want to show you something a little different here. So let's say let's get rid of this. So we're gonna play with the different operators. So let's do some things here. So let's see. So we have x divided by y. 8 divided by, we're going to change this to 81 divided by 7. So let's see what's going to happen when we run this. So there's our answer. Notice that this is not the answer that you want, because what about the remainder and all that stuff? Let's see how to get the remainder now. This is how you get the remainder. So that's it. So let's combine these two because we want to show remainder and so let's see. So we'll just name this short result remainder. And we're going to do another short result. And now we're going to have to print two things here. Remember in high school, elementary school, whenever you took arithmetic, you had that little part where you did remainder. So that's our remainder right here. So now and look at the naming convention. I'm using the same case here. And this is camel case, but notice that start off with the small r. You just can't rename this with a capital R. You're gonna run into trouble. We won't compile. So that's it right there. So now let's Control S, run this again, and take a look at our answer. So there it is. 11 remainder 4. And you might notice something else. There's a space, and soon as it printed the results, it printed the number right on the side of the R. So you put a space right here, and that's gonna make it so it's kind of like the result is right here. This is our result. So we wanted a space in between our results. So Even though I put a space here, that don't mean that it's going to be a space there. So with the computer, well, what's printing to the screen is everything inside these parentheses. So if I put a space in between the R, then that means we're going to have a space before and after results. See, this is the space before, and this is the space after. And that's why it's printing the way it did. So now that's it. So let's use different numbers. So we're going to use 971 divided by 7. And what's the remainder? We're gonna change that to 76. We want a big remainder. So now Control S save, and now F11 to run this thing. Here we go. Here go a nice one here. We have a big number here. So we have the divisor of 12 with a remainder of 59. So that's what I'm talking about. So the modulus operator is how we get in the remainder. This is called modulus. And just notice we had to create two charts, one to hold the results and one to hold the remainder. So now it's time for us to multiply some numbers. I don't like this keyboard. You might see me using a different keyboard next time. I just like how nice and clicky it sounds, but that's for another day. So let's change this to multiply. There we go. So let's uncomment this line right here, because this is where we declare our results remainder. And we could take this line out, and let's get rid of the use of results remainder right here. And now we shouldn't have any trouble compiling this thing. Let's see, I got rid of that, and there it is. So here's our answer, 8260. 971 times 76 is this big number, and the remainder part is still printing. We don't need this either. And there it is, results. And so that's it for right now. We just played with a little bit of arithmetic, and we just built a very basic calculator. So we're going to get into Boolean operators next. We're making our way slowly and surely towards the big picture here. So we just got done talking about math and all this stuff here, math and order of operations. So for our next video, we are about to start talking about Boolean logic and programming. This is whenever we about to really start making things make a lot more sense, because we were just doing these little basic programs, adding two numbers. So we about to start getting into loops and stuff like that. So all this stuff is building upon each other like you've seen here. So Boolean logic and programming is next. That's where we're going to introduce more operators. So this is the Savage Scientist Ed right here. And you already know that I'm the governor of the great state of Swampland. And until I make my next video, peace out.